Hello and welcome back. We are here for lesson 1-2, which is arithmetic series today. Our learning targets are, number 1, we want to write a formula for the nth partial sum of an arithmetic series. And number 2, calculate partial sums of an arithmetic series. It sounds harder than it is, I promise. So first we're going to talk a little bit about what a series is and how it's different than an arithmetic sequence. A series is the sum of the terms in a sequence. The sum of the first n terms of a series is the nth partial sum of the series and is denoted by S sub n is how we'll read that. And so a series is basically a sum of all of the terms or some of the terms or, a certain number of the terms. We want to know the sum of the terms in that sequence. And again, we're working with arithmetic sequences today. So here's the arithmetic sequence that we saw earlier in another lesson, 4, 6, 8, 10, 12, 14, 16, 18. And so first let's just practice finding sums. So if I wanted to find the sum of the first 4 terms of the sequence, I want to find S sub 4, well then I want to add together the first 4 terms. So 4 plus 6 plus 8 plus 10, I total those up and you're going to get 28. So that's finding the sum of the first 4 terms of the sequence. Now, if we want the sum of the first 5 terms, well, then we just have to add on that 12 to that 28. So 28 plus 12, so S sub 5, that's going to give us 40. And if I want the sum of 8 terms, so I have to do, the 4, 6, 8, 10, the 12, 14, I have to add them all up together. And when I do that, the sum of the first 8, the sum of the first 8 terms is 88. All right, now we're going to do some of that developing of the formula like we did in the last lesson. We want to develop a formula that will allow us to find these sums quicker than when we just add up the first 8 terms, because maybe we want to find, the sum of the first, 100 terms, like a teacher from the 1780s. So if you look down at the bottom, you see the Connect to History. There is kind of a fun story there. Apparently, there was a school teacher, a German school teacher in the 1780s, and the kids, according to legend, the kids were kind of misbehaving, and so he just decided to kind of punish them by having them find the sum of the first 100 integers. And so he thought, oh, that'll keep them busy for a while, but one young student was able to name that sum immediately. His name is Carl Friedrich Gauss, and he would become one of the world's most famous mathematicians. And he figured out how to find that sum using some mental math. And we're going to look at that process that he used today. And they don't say what grade he is, but for some reason I remember learning that he was like in 3rd grade or something. He was a little kid. All right, so looking back at part D here, number 1, it says, how does a sub 1 plus a sub 8 compare to a sub 2 plus a sub 7, and so on. So the first term in the 8th term, that 4 plus 18, that's what, 22? Well, then if I take the second term, which is 6, and the 7th term, which is 16, we also get 22. And the 3rd term, which is 8, and the 6th term, which is 14, guess what? Also 22. And finally, the 4th and 5th term, those two that are in the middle there, 10 and 12, also 22. So the sum of each of those pairs of terms is the same. So if I wanted to find the sum of the first 8 terms using a sub 1 plus a sub 8, well, a sub 1 plus a sub 8, we know that that's already 22. Well, 22 is not the sum of the first 8 terms. That was just term 1 plus term 8. But there were 4 pairs of those terms. And so if I wanted to find the sum, I could do it that way. Think, okay, there's 4 pairs of 22s, and that's 88. So now let's look at that series where we had little Carl, trying to add the numbers 1 to 100, and that would take a while for a little 3rd grader. But, you think about how many terms there are in this series. Well, there's actually 100 terms here that they would have to add together. And if we were to look at the pairs of those terms, so now you can see, in this case, you can see like, okay, I'm going to be putting 1 with 100 and 2 with 99 and 4 with 97. And well, the sum of each pair of numbers is actually 101. Okay, and how many pairs are there? Okay, how many pairs of numbers are there? Well, if there's 100 numbers, that means there's 50 pairs. So we could actually find the sum of the first, and this is what little Carl did. He was like, oh, it's just, 50 times 101, okay, which is pretty easy to do. 5,050. That's the sum of the first 100 integers. All right, so now using that idea, we're going to develop our formula. So on page 2, let's think of those now in terms of a sub 1, a sub 2, all the way up to a sub n. Okay, so any number of terms in a sequence, not just 100. So it says write an expression for the number of pairs of terms. Well, let's see. When there were 100 terms, it was 50 pairs. So in this problem, there are n terms. So there must be n divided by 2 pairs of terms. Okay. Now we took those pairs of term and we multiplied by the first term plus the last term, so the sum of the terms. Well, our first term, which is a sub 1, and our last term is a sub n, we would have added those together and we'd multiply by that n over 2. So now we can write our formula. So s sub n is equal to n over 2, that's the number of pairs, times the sum of the first term, a sub 1, plus the sum of the last term, which is a sub n. Now that is our big idea. That is a big formula for us. So how about we highlight that, and how about we change back to yellow to make it really bright? And that is important. Okay, so write that formula down. Okay, maybe you got it in the same spot you wrote the formula for yesterday. You've got a note card or a place in the front of your notebook. This is the sum of the partial, we call this the partial sum of an arithmetic series. So it's a formula for the partial sum of the arithmetic series. Okay, so make sure you get that written down and have it handy at all times, because now we are going to apply it. So we're going to do the same 3 problems that we actually did on the first page, but we're going to do them using the formula just so you can see. Not that we would need to. With a small sequence of numbers, we don't really need a formula, but we're going to see how we can use it. So for part A, I want s sub 4. Okay, so I want the sum of the first 4 terms. Well, how many pairs, first of all, we would want to figure out. So if there are 4 terms, okay, we would take 4 divided by 2. That means there's 2 pairs of terms. And our first term is 4, and our last term is 10. Okay, that's our 4th term. So 4 divided by 2 is 2 times 14. We get 28, just like we did before. If I want the first 5 terms, okay, s sub 5, okay, well this time it's 5 divided by 2, okay, and the first term is still 4, but this time the 5th term, okay, the 5th term is 12, okay, and so 5 over 2, what is that, 2.5, and then times 16, and we get 40. So the sum of the first 5 terms is 40, as we saw before. And finally, the first 8 terms, we're going to take s sub 8. We're going to take 8 divided by 2. There's 4 pairs, like we saw. And we're going to take first term 4, plus the last term, which is 18. 4 times 22, and that is 88. So it's a nice formula to have when you have a lot of terms in a sequence that we'll see. Okay, take a breath for a second. We got that written down. We're going to write another one down too. Before I turn the page, I just want to point out in this formula. So in this formula assumes that you know the nth term, okay? It assumes that when they asked you for a sub 4, or I'm sorry, for s sub 4, that you knew the 4th term, okay? And you knew the first term, and you had those pieces there. Well, you might not know that last term. They might give you a sequence and they haven't given you the last term. It's kind of just left off, you know, with a dot, dot, dot. And so we may have to slip in the arithmetic sequence formula that we wrote down yesterday in here to help us find the sum. And we can find the sum and we can find that nth term at the same time. And you can do it separately, but doing it at the same time is what they're going to talk about on the next page. All right, now we're ready to go to the next page. So, number 5. Okay, that's what we're going to talk about. That it says a second formula for finding the partial sum. So we're doing partial sum again of an arithmetic series is now new. This formula looks similar. You're going to see some things that are the same. For example, you're going to see that we have that n over 2 because we still want those pairs, okay? So n over 2, and then we have this, it's a 2a sub 1 plus n minus 1 times d. Now you're going to notice the n minus 1 times d is familiar, but why is it 2a sub 1? Well, if you think about it, the formula for the arithmetic sum that we just learned, oops, let me get rid of that. The S sub n formula that we just learned is n over 2 times a sub 1 plus a sub n. So you see how there's already an a sub 1 in there? Well, if we don't know a sub n and we still want to do the formula, we can go n over 2 times a sub 1, and then we can slip in, change that to green, we're going to slip in the a sub n formula. Okay, so what we're going to do there is we're going to be putting in plus a sub 1 plus n minus 1 times d from yesterday. Okay, and that'll give us, if we simplify it a little bit, then that's where that like 2a sub 1 actually comes from. So we end up with s sub n equals n over 2 times 2a sub 1 plus quantity n minus 1 times d. And that is a second way to look at this sum formula. So you want to put both formulas down, and I'll show you where it's a good idea when you could use that one. Okay. When we get to example 6, they actually tell us that's what they want us to do. So if we look at example 6 and we see that they want us to find, let's see, s sub 20, okay? Well, we don't know the 20th term, and we could find it, okay? Or we could do the sum and find the term all at the same time, which is a little bit easier. So I'm going to go ahead and do my s sub n equals, now in place of n, I know I'm going to want the 20, sum of the 20 terms, so I'm going to use 20 over 2, okay, and then I need 2 of a sub 1, which I know, 3, the first term is 3, plus, and then I need n minus 1, well my n is 20, so 20 minus 1, and then my common difference, did I find that yet? No, common difference is 8 minus 3, which is 5. Okay, so I have the formula written, and then you just have to calculate. So if I do 20 divided by 2, we know that's 10. Okay, so 10, and then I'm going to have to multiply by, let's see, that's going to be 6 plus, that's 19 times 5, which is 95. Okay, you can use your calculator for that. So it's actually 10 times 101. So the sum of the first 20 terms of that particular arithmetic sequence is going to be 1010. Okay, so that's a good place to see where we might want to use that. Okay, and again, you could do them separately, and maybe I can show you one of those if you want. So like in part B, they still want us to do the formula, so we'll still do the formula again. But then I'll show you where you kind of have a choice which way you want to do it. All right, we'll go back to red for this one. We want the sum of the first 18 terms, so I want s sub 18, which means I want 18 over 2. All right, now I have twice of a sub 1, so that's twice negative 2, okay, plus n minus 1, so 18 minus 1. Okay, and then the common difference, we got all these negatives. So to do the common difference, I'm going to do that on the side here. Common difference is going to be negative 4 minus negative 2, which is always a little tricky. with all these signs. So I'll add the opposite. And it looks like our common difference is -2. Okay, and then all we have to do is simplify. I see 9 times -4 plus, let's see, 17 times -2 is -34, which makes -38. So just a little bit of calculations, go to my calculator and get -342. And that would be the sum of the first 18 terms in that sequence. Okay, so if that formula feels complicated, you could use the two formulas separately if you want to. So for example, if we look at, let's see, the try these. Well, the try these A actually gives you the first and the last. So that one will be quick. Let's do that one quick, and then I'll show you the other one. So if we do the try these A, they want S sub 8, and they've given us A sub 1 and A sub 8. Perfect situation. So we'll use S sub 8 equals 8 over 2, and we need first term 5, last term 40. Add them up, we get 45 times 4, so 4 times 45, and we get 90. Oops, I'm sorry, we get 180. That was the easy fix. Okay, we get 180 for the sum of the first 8 terms. Okay, now in B and C, so I won't do both of those. Maybe I'll just do C since I've got room for it. In C, remember, we don't have the 25th term, okay? So we could use the formula that we learned in problem 5, or if you don't like using the big formula, you could do the two formulas separately. So like first we can use the A sub n formula. Like I need to find A sub 25, and I know that formula is A sub 1 plus n minus 1, oops, sorry, times D. And I know my A sub 1 I can see is 30, and 30 minus 1, n minus 1, I'm sorry, 25 minus 1. And then my common difference is going down, so it's going to be negative. So 20 minus 30 is -10. So I could do this part first, okay? So it's going to be, I forgot my plus sign in there, put that in there. So this first one's going to be 30 plus 24 times -10, okay, and then if I just do that, that's -240, so I get 30 plus -240, okay, which is going to be -210, okay. So I just found the 25th term. I know it's -210, okay, so that's A sub 25, and then I could go to the sum formula. So I'll change so it's not too crowded in here. So now I want the sum of the first 25 terms. So I could do 25 over 2. I know the first term is 30, and the last term is -210. Okay, sorry, it's a little squished in there. So I got 12.5, and then 30 plus -210, well, that would be -180. And we get -2,250. So that's doing them separately. But you don't have to do them separately because you have that embedded formula there. So that is completely up to you how you want to do that. All right. There's also examples in there that I didn't talk about because they're done for you already. So, I mean, you can always go in and notice like, hey, there's an example and they've got all the steps. So that's good to know. Just another place to look. All right, well, hey, we made it to the homework page. So that's going to be the end of the video. I'm going to have you try these problems. Okay, try the problems and then check your answers and let me know what questions you have. And when I see you virtually, I will be happy to go over any of these with you and show you all the steps through Zoom. I'll be using a whiteboard platform to be showing you some things through Zoom. So I hope that you are doing okay with this stuff, and this is we're done with arithmetic sequences right now, and our next video is going to go on to geometric sequences. So please make sure you're feeling confident on this stuff before you move on. And again, let me know what questions you have.